Welcome to Module 2 of the Fish and People DVD Education Resource. In the last module, we learned that the effects of fishing, subsistence, recreational, and commercial, have caused declines in the population of many species. We also saw that as human populations and markets increase, so does fishing pressure. We also learnt that technology can increase our ability to capture fish stocks faster than they are naturally replaced. In some cases, destroying fish stocks permanently. By talking with fishermen and elders, you may already know a lot about fish. Indeed, many people are very skilled at knowing when and where to catch them. But far fewer people really understand just where fish actually come from. And most importantly, how to make sure they keep coming. All animals need to reproduce for the species to survive predators and death by aging. So where do the baby fish, trochus, and giant clams come from to replace those large ones that die or are eaten? The process by which marine life creates new generations is known as the life cycle. Males and females of each species get together and release eggs and sperm, also known as gametes. The fertilized egg is called a zygote, and this single cell then multiplies and grows to become a larva. The plural of larva is larvae. Most marine life has a temporary, microscopic, larval life stage. Given a few days or weeks, these larval phases metamorphose to take on their adult form. These critters are incredibly small, and many of them could fit into a single drop of seawater. This microscopic world of plants and animals we can't see is known collectively as the plankton. Think of them as larval lifeboats. They are nature's solution to travelling vast distances across the trackless oceans by taking a free, invisible ride on the currents. Thousands, even many millions of eggs are released by spawning adults. Fish, giant clams, sea cucumbers, corals. In fact, almost all marine creatures spawn to renew their species and disperse their larvae to new locations. Fish larvae are tiny and colourless and can float on surface currents for days or weeks. When they are ready to settle, they will swim towards the smell of a reef or the sound of its waves, for days if necessary. They time their arrival to be at night, and once they crash land, they change shape and colour such that by dawn the next day, they appear as juvenile reef fish. All the creatures we know and love, fish, corals, clams, trochus, lobsters, and sea cucumbers, all use larval phases to travel around the oceans and regenerate their species. Like spaceships, they drift on the currents in their millions. By spawning this way, each species is playing a game that has worked well for millions of years. If you release enough larvae, eventually some will survive the predators to arrive at another reef and continue the species. In summary, there is nothing magical or mysterious about where fish and other reef species come from. It's just hard to see. For a fish species to survive, it must be able to complete its life cycle, just like people. A species must also be able to disperse to other locations. Think of spawning and dispersal as an insurance policy against natural disasters. Life is a risky business. Millions of larvae are launched, but very few survive to become adults, usually less than 1%. Scientists refer to this process as a larval lottery. These biological traits have evolved to cope with the problems of the natural world. Millions may die, but enough make it through to let the species survive. Unfortunately, the increase in human populations and the way we harvest species is occurring faster than the natural world can cope with. The equation is simple. If our fishing activities reduce the egg production of a species too much, then it will not survive. Overfishing the adults of a population is the quickest way to destroy it. If you remove enough adult fish, or turtle, or dugong for that matter, then reproduction is no longer successful and the population dies out.
And if people can understand that they have to spare the big fish in order to give birth to little fish, they have to spare the one that is carrying the eggs and the babies in order that they have new fish come up. This is important for the students to learn in school.
In this section, we have learned that most marine animals reproduce by shedding eggs and sperm into the water. Fertilized eggs hatch into larvae, which float in the plankton for varying amounts of time. And if they are lucky, end up at a new reef where they can settle and become juveniles. The number of larvae that survive until settlement is related to the number of spawning adults. So if fishing removes too many adults, then the number of settling larvae decreases, and population growth slows down and eventually fails. So now we know just where reef creatures come from. We are going to look more closely at the strategies used by different types of animals. For fish, being able to swim might make finding a partner easy, but getting together in big numbers at the right time of year takes more than chance. It is actually made possible by the complex interplay of natural signals like the moon, tide, day length, and water temperature. Any good fisherman already knows this. That's why people fish in certain places at certain times. We are using the same cues that the fish do. When they are ready to reproduce, fish form single-species schools called spawning aggregations. The act of spawning releases eggs and sperm into the sea, which leads to external fertilization. It is usually the female that takes the lead in a spawning rush. She releases her eggs into the water, and the males compete to fertilize them by releasing clouds of sperm. This can only be done by sexually mature animals. So only some of the population can spawn, and only after weeks or even months of egg and sperm preparation, usually in the warming waters of late spring through summer. Typically, the larger, older animals produce many times more eggs than the smaller, younger ones. For a fish species to reproduce successfully, it must have the correct number of individuals of a given age, size, and sex. Just as with people, who have babies, children, adolescents, and adults, so it is with fish. So having a lot of smaller animals doesn't mean the population is being replenished.
Spawning aggregation is a time where pretty much all of the fish everywhere come in. It is like everyone descending to watch a soccer match between Australia and Japan being held in Honiara, and pretty much everyone descends there. So imagine if you take a big bomb and you drop it in the middle of the pitch. Pretty much the whole population is going to die. And that's what happens when you fish out a spawning aggregation. So it is very, very important that we protect spawning aggregations.
The key message here is to have fish for the future. It is not just the number of fish that is important, but also their age and size. Now let's look at animals that are not so mobile. Animals like clams, trochus, snails, and sea cucumbers or bêche de mer, cannot move great distances to aggregate and spawn. They need to be close to each other to be successful. For bottom-dwelling animals like giant clams or sea cucumbers, the males released sperm first. Then nearby mature females detect the sperm in the water and release eggs in response. Spawning is again cued by the moon, tide and temperature. It can last for hours and is often repeated at the same point in the lunar cycle over the summer months. But there's a twist. Because clams cannot move to be together, they rely on having high numbers to be successful spawners. If the density of clams is too low and there are too few individuals, then the chance of spawning success is also low. Without any new larvae or juveniles, over time, the clams gradually disappear. In this section, we have learned that mobile animals, like fish, have different ecology to stationary animals like giant clams and sea cucumbers. We learned that for species with limited or no mobility, if the distance between the spawning males and females becomes too great, usually because of overfishing, fertilization cannot succeed and reproduction fails, and the population can no longer grow. For people who depend on marine resources for their livelihood, these are the real facts of life, and we ignore them at our peril.
Well, that's one of the main things that most of our community people don't understand, that if you continue on removing animals and get them more far apart from each other, it will be really difficult for them to breed.
The key message here is animals that live on the seafloor need to be close together to spawn successfully. In the next module, we'll explore the biological reasons why some species respond differently to fishing pressure than others.
If you want to live, to survive that long, take care of the sea too.